So thank you very much, everyone, for joining Kit and I today. Um, just a couple of things before we go ahead and get started. If you have questions, please drop them inside the chat. We have natural progressions, spots where we're going to pause and kind of talk a little bit more about what we're showing up on the screen. So if you have some questions, we'll take a look at them, and if it makes sense, we'll definitely answer it right then. Otherwise, we might hold off till the end of the slide deck before we go ahead and answer any sort of those other questions. But without further ado, let's go ahead and jump right on in. As John said, my name is Bob Walker. I'm a field CTO at Octopus Deploy, and I've been with Octopus Deploy since 2018. However, I think the real star of the show is Kit because he's the product manager really focused in on Kubernetes. I don't know why I put 2020.x. Sorry about that, Kit. Kit, if you want to do a brief introduction.
Yeah, I did NPM. I did Octopus a year and a half ago. And yes, as you said, our team is fully focused on making deployments with Kubernetes better. So, and I like the X, it could be like maybe 2021,
Yeah, there you go. Awesome. So for a bit of an agenda today, we are going to be going through the white paper. There's going to be a couple of things. We're going to focus primarily on first aligning Kubernetes adoption to your business goals. We're going to have a brief discussion around that. Overcoming some business challenges that you might encounter when you start adopting Kubernetes, specifically when you start focusing on continuous delivery at scale. And then finally, we're going to have a pretty lengthy discussion, I think, about overcoming some of the technical challenges that you might experience as leaders. So I'm going to go ahead and jump right in to aligning Kubernetes adoption to business goals. Now, Kit, I think one of the things that we've seen is that if you don't align a Kubernetes adoption to a business goal, it tends to get kind of pushed back to the side. Are you kind of seeing something similar when you're talking to your customers?
Yeah, all the time. If you don't know, basically, business goal is why you're doing this, right? If you don't know why you're doing this, you will end up doing something completely random. And then half a year later, your budget will be cut. So you won't have any funds to continue the project, and then you probably won't have any people. And then it will just naturally dies out and no one will pick it up later. And then what's worse, and I saw it a couple of times, you can have a bad reputation in the company, and then the whole company will think about, oh, we tried Kubernetes, that didn't really work, so should we stay on something which we trust and know about? So yeah, I would say this is like the first and the most important part.
Yeah, I 100% agree. We talked to some customers and they would talk about, oh, we want to move all of our workloads onto Kubernetes by 18 months. And I'm like, well, what's your driving business case? I'm like, well, no reason. I'm like, you need to have a reason to do this. So we're going to discuss a couple of use cases. Selfishly, we're first going to talk a little bit about Octopus Cloud because I think it makes sense in the context of aligning to the business goal. And then we're going to have a little bit more of a generic example more focused on a B2C type of experience. So first up, when we talk about business goals, let's talk a little bit about Octopus Cloud primarily, where our business goal is we want to make Octopus Cloud the default hosting option. So we have both the self-hosted version of Octopus Deploy as well as a SaaS version of Octopus Deploy, if you're not familiar. And we want Octopus Cloud to be the default hosting option specifically for all of our net new customers, but as well as all of our existing customers as well. But at the time when we started putting together some of these goals, Octopus Cloud really ran on EC2 instances, and everyone got their own dedicated EC2 virtual machine. And so we were running into some incremental scalability issues. So what I mean by that is that we wanted to have the ability to say, instead of giving them 2 virtual CPUs, give them 3 virtual CPUs, or give a customer, instead of 4 gigabytes of RAM, give them 5 or 8 or 16 or 24 gigabytes of RAM, but without increasing all of the additional CPUs or anything along those lines. And honestly, EC2 just wasn't giving us that type of capability. The other issue that we're running into is resource utilization and density, where if you looked at any sort of typical usage across the board, at no point were all instances at 100% utilization. And so without that, the problems with that scalability and that utilization made it really hard for us to say, yeah, Octopus Cloud makes a lot of sense for a default hosting option. When our customers, they get that by self-hosting a lot of that stuff. Yeah, they can add more CPUs and RAM and all that other stuff if they're self-hosting on their own data centers. Now, one of the fun facts when I was talking to the cloud platform team is that originally when we were considering, improving Octopus Cloud and making it the default option, Kubernetes wasn't even originally considered. But as we looked into it more and more, and we looked at different options, Kubernetes just made much more sense to help us achieve that business goal. It provided much better scalability options and much better resource utilization. But we also got a ton of other benefits on top of that. We got things such as self-healing and easier upgrades and more. So now that we've talked a little bit about kind of a concrete Octopus Cloud example, we're going to move a little bit more on to B2C. So we're going to talk a little bit about some consumer websites. And the reason I picked this is because it's typically pretty easy to wrap your head around something like this, because almost everyone has to deal with some sort of consumer website at some point in time. And if you talk to them, majority of them are going to be like, well, we have to meet sales and we have to meet growth goals. But at the same time, as you increase usage, as you increase your user base and traffic, there's a direct correlation between your website performance and revenue. If someone's waiting for 1 or 2 seconds for the page to load, they're almost immediately going to navigate away. So if you don't have a good user experience, then they're just not going to want to stay on. And so what we see is like there's different types of scaling events where so like if you talk about restaurant online ordering, I don't know who's traveled recently or has gone to McDonald's recently, but um, I'm sure you've noticed that now there's more of these touch screen. You can order directly at the restaurant, like almost online, using their online order form instead of walking up and talking to somebody. And so because of that, I mean, you can imagine as every night when the dinner rush comes through, there's going to be a tremendous amount of load, and you want to have a very robust and very performant online ordering experience because you got to get those orders through as fast as possible. On the flip side of that, maybe you have hotels where you have more weekly scaling. So from Thursday to Saturday, you have to be running at max capacity to handle all of the additional check-ins and all the additional traffic that's coming in for that. But it could also just be monthly or quarterly scaling for like e-commerce websites for like back to school events or holiday sales or anything along those lines. So there's a lot of those different types of scalability issues they might run into where Kubernetes can help solve that and make it much easier to do that. But again, you're lining that scalability. We want to have better scalability with your business goal, which is we want to meet our sales and growth goals for something like this. And we need to have a very performant experience. Um, Kit, can you think of any other examples where we'd want to align business goals from what we've seen or what you've talked to?
Yeah, I think my favorite one would be edge deployment. So
Yeah.
I talked to a few people who have a bunch of restaurants or I don't know, clubs, swimming pools, anything where you think about having some local automation. And also, especially if it's a restaurant or like some financial org, you don't want to be really dependent on the network, and one day it will go down. So you need something running locally so your business will survive, even if it's like downtimes. And in this case, you don't need any. Your app doesn't really require a lot of CPUs and RAM. You don't need the whole data center locally, right? You don't need such just a very simple app constantly running. But then you have a choice. You can either think about, well, okay, I have maybe like 5, 10, 15,000 different places across the globe where I want to order and supply the same type of equipment and then maintain that and think about how I deploy there. And then it won't be homogeneous anyway, right? So at one point you have 15 different options or maybe 50, which you have to think about when you deploy a software. But what if you run Kubernetes? And we saw a couple of customers who did exactly this. So doesn't matter what kind of old, maybe obsolete hardware I have. Maybe it's my old laptop or just, something I bought for $100. But I still can run container there. I can run Kubernetes there. And I can deploy to all these 5,000, 10,000 Kubernetes instances through the same API with the same tool. And ideally, I don't need to do any special configuration for each of this. And that's another, it's less about scaling, but it's more about how you can utilize this one way of talking to all the places through the unified API. This, I think, another good example.
That's a really good point, especially since you know that this container is going to work, and you have that common API, and you can change up maybe a few other configurations. But that's a really cool point on top of that. So I'm going to jump over a bit, and we're going to talk a little bit about overcoming some of the business challenges that you might incur as you migrate over to Kubernetes. So, Kit, I know you have some thoughts around this, specifically around understanding responsibility for decisions and operations.
Yeah, so in my opinion, this is maybe the biggest problem which people face, but unfortunately don't realize soon enough and then struggle when they move on in the Kubernetes journey. And this is like, how can I ensure that I'm because Kubernetes is a complex system, right? And it's not like you can have a cluster per each application or a cluster per microservice. That just makes the whole thing meaningless. So it's meant to be hosting multiple apps. It's meant to work for multiple teams, and it, as we discussed, meant to scale. And if you think about this, you naturally come to the need of some central point of management, some ownership, and shared responsibility with different people. And if you don't do that, oh yeah, you will run into trouble. Can we move to the next slide?
Yep.
So the question here is, at some point, you need to answer a few questions for a company, and this answer will actually help you to plan the whole Kubernetes project. The first one is, who actually owns the clusters and infrastructure? Is it each individual team, and you give them a way to provision this in the cloud? Is it some centralized team, like platform team, a structure team? Who will owns it in a way that ensures that it's always cost efficient and reliable, and it's in the region you really want it to be? Um, who owns the software delivery pipelines and best practices? Again, at some point, I saw a customer who had maybe 50 teams and 50 ways to deploy to Kubernetes. And that's fine to the point where you have an issue and you need to debug, and then no one knows how each individual app works and how to redeploy them. What happens if you have a major event and you need to recover all of these apps within a couple of hours? And finally, who would actually define best practice for that? How would you ensure that you follow the same pattern, you deliver actual reliable software? So all these things, you must think about them in advance, because if you don't, cleaning this later would be way bigger task. If you know that, as soon as you know that, you can move on and you can answer the second group of questions. And this is now when I know the big ownership, I know who owns my infrastructure pieces and the Python piece, I know who give the tool and give the best practices. Now, who is actually doing the job? This might sound like an easy question, but it's actually not. If you think about this, uh, who is building pipeline? We tend to think that individual team is doing this, right? But for Kubernetes, it might be very complex. And people in the Kubernetes pipeline, there are a lot of things like security and reliability which you might think about, and might not be easy and obvious for people. So you need to think about this and think about how maybe teams can collaborate on this. Are there any templates? Are there any guidelines? Are there strict requirements? Um, who actually picks and configures tooling? And we're not talking just about CD tooling. We're talking about tooling like monitoring, tooling like ephemeral containers which you might run, tooling like security checks, and I don't know, server mesh. So someone should pick that, but not just for all of them. Sometimes individual teams need tooling. Do you need to provide them some guidance? Do you want them to choose like whatever they like? If so, how will you ensure that it's secure, after all, and don't consume too much resources, for example? Who is responsible for deployments? And this is actually a very tricky point, meaning who is responsible for deployment to be successful and run successfully all day, every day? So again, it's easy to say it's just the team, and definitely it's a good way of thinking about this because, well, we don't want, we'll talk about this later, but we don't want to throw things over the fence. But what if they don't own deployment pipelines or infrastructure? So that's the platform team then, but they don't develop the app. So again, you need to find this balance and basically introduce the idea that these people should work together and give them the frameworks and give them support how they can work together. And finally, who manages security and maintenance? Too many times I saw that no one actually thought about this question, and then the answer was no one. It's like nature, we'll figure it out. The true reality is you won't, and most likely no one is probably the worst answer ever, right? So think about this, right? Who ensure that we have the right security policies? Who ensure that we actually know and practice and plan how we do cluster updates, how we do recovery, just recovery, how we provision the new cluster, how we kill the cluster, how we actually clean all the infrastructure configuration. So yeah, just think about this. Bob, have you maybe seen an example as well where people didn't think about this and then struggle?
Yeah, I was thinking through. I don't want to throw any names out there, but when we would talk to some customers, and it would be more along the lines of they didn't they basically didn't answer any of these questions. They didn't start thinking about kind of like this at scale where they kind of let each individual app team make these decisions. And you end up in a situation where if you say had 10 teams or 50 teams, you had 50 different ways of doing something. Uh, Not only that, you also had 50 different possibilities. If anyone's looked at the CNCF landscape and all the different ways to do something like that, and there's so many different tools out there. I mean, you'd see some people they would use, say, Jenkins. Other teams they would use GitHub Actions. Other people were using Argo. Other people were using Flux. Other people were using Octopus. There was just no consistency, and so it made any sort of management, any sort of maintenance, it was really just a big pain for them to deal with something like this. And oftentimes this we would come in and we would start talking to some teams and it'd be like, okay, they're gonna a lot of them are gonna have to shift and move things around and kind of standardize on a number of these different things. And so, yeah, it ends up like you said, it ends up being a bigger headache towards the end rather than kind of spending a little bit of time up front will save a lot of a headache later down the line.
Okay, let's move on to the next big
Yeah.
question. Let's say we figure out who's doing what, who's responsible for what at a high level. Now the question I hear a lot is like, should we actually train people? Or it's not even the question. The question is, should everyone knows Kubernetes or not? And then the answer is, well, maybe they should. And they should because of two reasons. First of all, you don't want to lock people into there is just one group of experts who knows everything about Kubernetes and you don't understand a thing, so you're just afraid of touching this. I saw this pattern too often. And then you don't want to have this idea then people afraid to touch something, so they don't feel ownership, they don't feel responsibility, therefore they don't really care. Therefore, as soon as they thought about, like this typical phrase, it works on my machine.
Yep.
So these days are long gone for VMs and other deployments, but they can go back. And again, it's happening with Kubernetes when people just don't feel. Imagine this: people don't know how to write their own YAML files or Helm charts. They just use some template provided by platform team. They don't really know how the deployment to Kubernetes works and what's going on when they just created the new container. It somehow magically appears in the cluster. They don't really understand all this idea of multiple replicas running, cluster moving forward between the nodes and how the network works. Therefore, they just say, okay, hope it works. And if it doesn't, I will just call someone and they help me. And then the further you go in this process, the further the far further you are from understanding of how the platform works and from being able to actually optimize this platform. And then just a couple of weeks, not more, okay, a month ago, I talked to a person from the platform team and he told me that 85% of their load is constantly answering questions from applications team when it help with debugging the pipelines, debugging the apps, understanding how to build configuration, and it's just not sustainable. So the whole point of this section is answer the question, yes, people should learn Kubernetes, and every team should still own their deployment and still own and understand what's going on, but that won't happen automatically. You just can't expect the people in your company, especially if you have a big one, will just all learn the things. The reality is they won't, and then you'll struggle with all these things. So when you think about Kubernetes, start thinking about how you will implement some training program inside a company. How will you upskill all the people? How will you establish maybe the base level, which everyone should know and go for some training and maybe even having some certificate. But you also may think about some champions, which you might have in each team. And this champion might have like level 2, level 3 knowledge. So way more advanced. And then you should think about like, okay, what my platform team should know. And that's maybe even one level above. So think about this as a program and implement this as a program. Don't just leave it to the people hoping that they will find their way through and maybe you learn some stuff. Bob, what do you think about this? What's
Yeah,
your experience out there?
yeah. I think this was when we were writing the paper. This was one of those areas where like both you and I were just like, just basically building on top of one another. Uh, I 100% agree on something like this. It's very tempting to have that centralized team handle all the responsibility for deploying to Kubernetes, but at the same time, you're really putting yourself in a bind later down the road because, as you said, no one really understands how the intricacies of how Kubernetes works or even how their application works. And it's fine if you have a simple application and all it is just a website with maybe a database backend and that's it. But when you start getting into more of the like microservices, when you have to start worrying about service meshes and have to worry about how am I going to communicate between all these different things, then it becomes much more complex. One of the other things I thought was really interesting is when I was talking with someone a couple of weeks ago, and they work on a tool that helps basically right size containers in terms of CPU and RAM resources. So they're doing research on that, and they were saying, oftentimes when a platform team would ask, okay, how much resource, how many CPUs and how much virtual CPU and how much RAM do you need? They would tell them, well, this is what our VM has, and so they typically people would naturally grossly over provision the amount of resources they needed for their container. If you understand Kubernetes better, if you understand how the different milliamps and milli CPUs and everything like that when it comes down to those resources, it will even be more cost effective even because now you're not grossly over provisioning. But again, it's just back to like you said, having this training, having this certification and finding those champions, find the people who really want to learn Kubernetes versus the ones that, yeah, I'm going to learn Kubernetes, but just enough to do my job type of thing.
Yeah, makes a lot of sense. So should we move on to the next problem, which we also hear a lot, is vendor lock.
Oh, yeah. This is one of those ones that we'll hear from customers and they're like, well, we're looking for something that's completely 100% cloud vendor neutral and I can run both hybrid and cross GCP and AWS and have it be completely vendor neutral and something like that. One of the advantages of Kubernetes is yes, they make it super easy to move between providers, but at the same time, I think there's always going to be some vendor lock-in that's going to occur. And when we looked at this, there were kind of really two levels of vendor lock-in. The first one is the vendor lock-in where they'll provide plugins. So for example, if you host on Azure, they're going to provide a plugin for Azure file storage. They're going to make it super easy to connect to Azure SQL because they have a vested interest in making that super easy. And so if when you go to Azure, you might write your manifest files and your Helm charts in a specific way that will target those types of plugins. But if you switch over to, say, AWS or GCP, generally there's going to be a few minor modifications, and that's perfectly fine on something like that. Really, the vendor lock-in that I get concerned with is if I ever hear about anyone who doesn't provide that native Kubernetes experience where you don't get access to the Kubernetes API or the kubectl or anything along those lines. So if you were to see a vendor that would say basically something like that, that's a huge red flag and you should find somebody else because I can guarantee there are cloud providers out there as well as self-hosted options out there that provide that native experience, but they just extend it a little bit, but not completely obfuscating away any sort of access to the Kubernetes API or kubectl or kubectl, if that's what you prefer to call it. So yeah, something like this, Kit, I'm kind of curious about. Have you come across any sort of having a true vendor neutral multi-cloud solution, or is that more of a pipe dream?
A few examples where people got really close to that. Again, I'm not, this is about the first thing to discuss the business goal. I'm really struggling to understand sometimes if it actually made sense to go that far. But yes, you can do something like you can have bare metal in the cloud or just VM instances like EC2s, and you can install Kubernetes yourself on these VMs. And you can manage through adding like more nodes or less nodes. And then you can even think about something like having a unified internal platform where you abstract the cloud provisioning even and you just for the admins and your developers, you don't even know the exact cloud API you're talking to. That's all possible, but then, as you said, if I already have like the unified Helm charts or customization files, and I can provision them to any other cloud, it doesn't make sense actually to go further and trying to avoid managed Kubernetes services like completely, like never run AKS, for example, never run EKS, etc. So I don't think so. It's doable, yes. You will still have, unfortunately, you will still have to deal with the cloud. You still have vendor lock unless you want to build your own data center, but then you
Yeah.
jump into another lock. But yeah, so doable, probably not always meaningful.
I think we were talking to a person last week, and basically he said, why don't we solve supporting one cloud provider first and then worry about solving multiple cloud providers next. Because the first ones, that's a big enough problem on something like that. And that leads us naturally into overcoming some technical challenges. And this is going to be a little bit longer of a conversation, but I'm really excited to talk a little bit more about this because we can dive a little bit more in the technical weeds in certain aspects. So first up, the question becomes containerizing existing applications. And I know both you, Kit, and I, we have some thoughts on that. So I'm going to let Kit handle some of the beginning part of this.
Yeah, so in reality, we don't always start Kubernetes migration from writing a new app, right? We're actually thinking about moving something we have to the platform. And I guess hopefully for some good reason. So we're thinking about maybe we don't have enough scale, maybe we want to go into other regions. So whatever the reason is. And then when we're thinking about moving the existing app to a new infrastructure, there are a few things I believe we need to consider. So the first thing is how is the application hosted today? So literally like what are we doing today and is it close to how we're going to host it in the future? Therefore, close meaning how easy it is to migrate, right? So if it's now already Linux-based container, maybe we use Docker, Swarm, or something like this, then migration might be easier. We already have something and we're already following the similar-ish concept. However, what if we have Windows-based application and it haven't yet ever been containerized and it's just running, I don't know, as we developed like 20 years ago? It's a completely different story, right? What if we use some libraries or some frameworks which just not really compatible to Kubernetes? And what if our application is actually stateful? What if we heavily rely on maybe multiple databases? Maybe we use storage heavily, not even databases. A lot of apps would use just file system. And how are we going to move this to Kubernetes? Too many times we saw that people just jump straight in and start to move stuff into Kubernetes without thinking about any architectural changes. And then we end up with this quite actually popular projects right now on CNCF, like how can I run VM as a container in Kubernetes? You can do that. Now you can. Is it a good idea? Maybe not, right? So, yeah, back
That's
to you.
Yeah, as I say, that's one of those running a virtual machine in Kubernetes. It's like you can, but should you type of thing. Yeah, that and in fact, when we migrated Octopus Cloud from basically running on Windows VMs onto Kubernetes, one of the big challenges that we faced was there were certain libraries that we had that didn't support .NET Core. They basically have been end of life, I think, since like .NET 4 or .NET 4.5 or something like that. And we had to find replacements for those. Thankfully, they were few and far between. It wasn't every single library, but those are some of the things that you just need to consider as you do some of those brownfield migration. But if you want to do a brownfield migration, there is legitimate reasons for doing something like that, so you don't have to rewrite the entire application. But if you want to do greenfield migration, where you're going to slowly say peel away certain functionality from your existing applications, that's completely possible as well. And so this is really more along the lines of just incrementally migrating new services and new functionality over to Kubernetes, but still keeping the legacy application around. This is actually known as the strangler pattern or the strangler fig pattern on something like that. It's where you're more focused on migrating the business rules, not the actual code. So the best example I could come up with is imagine that you are given an input string and your code's supposed to do some sort of transformation to it and then give you an output from that input. As long as the output matches what you expect from based on the input, how you accomplish that, it doesn't really matter. It could be running in JavaScript on containers, or it could be running on Java on a Linux server. As long as the input and output is the exact same, most applications aren't going to care on something like that. So really it's focusing in on those business rules. And then you're going to need some sort of facade layer to make sure that you handle the traffic between each of the systems. And this is where I think it gets even more complex. And I think this is where one of those issues where if you're going to be migrating a monolith, this is going to require careful planning as you start pulling features and functionality away. Because without thinking through something like this, you can end up in a situation where you're in a really big bind on how you're going to handle something along those lines in terms of your migration. I ran into this where we were trying to basically adopt this pattern as well, and there was this one piece of functionality that really depended on the data to be in a certain state, and if it wasn't in that exact specific state, everything else started failing after the fact. And so it's just one of those things where sometimes you just don't even know until you get into it and start doing it, but it is going to be something you're going to have to think about as you start migrating and start building out this new features and functionality. It could take quite a bit of time. Again, where you hear, I want to migrate all my workloads in 18 months, it's like that's pretty ambitious if you really think about it, especially if you have big monoliths that you're looking to break up and migrate and everything along those lines. Now I'm going to move over and talk a little bit about some container misconceptions that we run into. Since we've been talking about brownfield and greenfield migration and everything along those lines, probably the biggest misconception that we see is that containers are just headless VMs. No, they're not. They're meant to be immutable. But we often hear about, or we actually get asked questions, not as often as we used to, but in the early days of Kubernetes and containers, people would ask us quite frequently, can't we just install your Tentacle agent onto the container so we can make changes to the container while it's running? It's like we could, but that completely breaks how containers are supposed to work. You shouldn't be doing things like incremental changes anymore. And we often hear about build pipelines and software delivery pipelines where they're just focused on delivering the deltas between one version and another. That's not the case anymore with containers. It's you build the entire application that you need with all the source code and everything like that, all the libraries inside of that container. And if you make any sort of change, then you have to do that. And your software delivery pipeline, it's probably going to have to change if you were previously doing Delta. And so that's something you're going to have to consider on something like that. I'm kind of curious, Kate, have you seen other use cases where people are treating containers as headless VMs?
Yes, I saw that a few times, and I think this is, as you said, it's slowly going away. And people don't really try to, sometimes they try to execute some scripts after deployment. So I deploy my container, then I do something else with it.
Yeah.
And that's not ideal. But again, it's happening less and less. What I still see is how sometimes the app designed and people think about containers something which should live long, which should survive, and ideally should never die unless we want to deploy the new version. And that's, in my opinion, also not ideal. Sometimes you have to do that. Sometimes maybe you have an absolute app and you're still moving through this migration upgrade process. But as soon as you can, I guess it's important to configure containers and the whole app developed in a way that, okay, containers must die. They should die often. It's okay if we move them from node to node, meaning like kill them and create a new one. It's okay if we kill them when they scale up and down. And sometimes that's actually the best way to resolve an issue with container. Instead of trying to debug it and go in and fix it, just kill it and create a new one. So I think just keeping this in mind, and this is also a huge difference. That's where we should start planning this from the app design, I think, in the very early days, right? So yeah, and this is the part where I still think it's not happening often enough. And I guess this is what we should consider.
Yeah. We have some older T-shirts that are floating around. I don't know if you've seen them, where we basically say treat your applications or your application hosts like cattle, not pets. And when you start talking about having your containers be headless VMs that you monitor and they have to stay alive regardless of anything, that's a pet. But really, your containers should be cattle. They should be just, you can change them out whenever the case may be or anything along those lines. So I'm going to move on a little bit and let's talk a little bit about planning for a hybrid infrastructure. And I think when we mention the term hybrid infrastructure, people immediately go to the point where it's like, oh, you're going to run in some of your workload in the cloud and then some of your workloads be self-hosted. What I'm really referring to on here is that back to the brownfield migration where not all applications can be containerized. I would also say don't try to containerize all your components unless there is a very specific business case or hosting requirement. So typically it's right around the database and the file storage is going to be the big one for me. But if you're running things, say, at a restaurant, yes, absolutely. You're going to want to have your databases running at your restaurant. Same thing with file storage. That should be running on the Kubernetes cluster. But if you're doing a managed Kubernetes cluster, such as EKS or AKS or GKE, leverage the managed services that are out there that already built the database and file storages, because then you don't have to worry about the database container suddenly randomly dying, or having how you're going to handle backups, or how you're going to handle file storage, IOPS, and everything along those lines. Those managed services, they're there to help you out, and it's already built, and you don't have to do a lot of that management stuff. That's all provided for you. You have to pay a fee, but that fee is going to be certainly a lot less than having to build out a process and have a person monitor it and everything along those lines. Now, Kit, I guess, is there any other application host types that you can think of that you wouldn't want to containerize or run inside of a Kubernetes cluster?
Yeah, I mean, database is probably the main example where I would not jump into this straight away. Although Kubernetes is getting better with stateful apps,
Yeah,
and I think this is one of the goals for the platform developers. They want to be better and better, and eventually become a great platform to host that. But still, for now, as I said, just it's easier. Just use managed services. And I think it's also we can extend this to any um, massive monolithic stateful heavy apps.
yeah,
I think sometimes if you have huge video processing app and it's always loaded, it works with a lot of files, and it's not like you can, you know, do a lot of parallel processing there. So it's basically one app running. Maybe, yeah, maybe it's just makes sense to run it on big VM still and run it like this, right? Again, most apps we can move to microservices and make them stateless and run Kubernetes. But some of these big ones, maybe not yet. And maybe it's just like maybe it's the last step of the migration. Who
yeah.
knows?
Don't do the don't do the most complex application first that takes up all your time. See if there's those quick wins that make your life a little bit easier. Now, I'm going to talk a little bit about, since we talked about just recently not containerizing all your components, let's talk about some of the software delivery strategies that are out there and some of the things that you'll need to consider. Um, so, essentially, when it's all said and done, really all the tools that are out there, it's when you boil it down to everything, they're really just wrapping kubectl or kubectl apply or the Kubernetes API. And so the tools that are available, they automate the invocation of those commands or the orchestration of your Kubernetes API or anything along those lines. That's primarily what their focus is going to be on. Now, that's a pretty big shift from traditional application hosts when you think about it, because if you're deploying to, say, Azure Web Apps, you have to give it a series of commands to run, or you have to, if you're deploying to, say, virtual machines, same thing. It's a very set series of commands, CLI commands or PowerShell scripts or anything along those lines, where basically you're building out what you want the application to look like. Whereas with Kubernetes, it's mostly going to be around that desired state, where you're just saying, okay, Kubernetes, I have this desired state, go ahead and apply it using kubectl apply or the Kubernetes API. And so as a result of this, in this mind shift that happens, I think what ends up happening is a lot of new tools and concepts, such as GitOps, which I think there are a lot of really great things about GitOps. And I'm not bashing on it. I'm just saying that oftentimes they're introduced and adopted when you don't have a consideration for scale. And one of the big considerations for scale that I see out there is going to be around how do we have environmental progression. So when you have your desired state stored inside of, say, a Git repository with, say, your manifest files or your Helm charts or something along those lines, you're going to have environmental differences. And so then the question becomes, how do you handle those environmental differences? Do you have a folder per environment or a branch per environment? And from my point of view, I would say that's a big red flag. You should typically do your best to avoid having exact copies in separate folders or separate branches, and really decouple how you deploy from that environmental configuration. Define that process once and reuse it, and any environmental differences should be handled as variables. You shouldn't have exact copies of your deployment process per environment or per location or anything along those lines. But that's just one thing that I think that we make note of when we start seeing these new software delivery strategies. One of the other things I know Kit has done some research on is around observability.
Yeah, so I actually really like this topic. And I think that as far as I understand this shift, if I describe this shift usually when I asked, is before Kubernetes, we had two levels, if we can think about this like this, of observability. So the main one, and it still is, and nothing changed here, is actually observability of the app. What's going on, how different services talk to each other, where they see the most of delays. Um, Maybe we have some errors generated in the app, and with like how much resources we consume, etc. This is still important. We need to do that. The second level was always overall performance of our server VM. We also cared about, well, how much free CPU and RAM we have. We didn't want to run out of disk space. Our network should be performant enough. And again, with Kubernetes, it's all still there. However, Kubernetes introduced this new level in between, in the middle, where we actually not always have enough observability. And this is about my configuration. So if you think about Kubernetes cluster as a multiple servers, multiple nodes running, and knowing the health of each node and CPU and RAM and network is really important, it doesn't answer the question of how my app is feeling, right? So if cluster applied my configuration, if all the containers provisioned, um, if I don't know, avoided any deployment errors, and my app monitoring on the other hand also wants to tell me this. So in Kubernetes world, we almost need to think about this extra layer where we actually observe our configuration and all the resources deployed, and we observe if the cluster achieves the desired state. So this is different because to answer this question, we need actually be aware of two contexts. On the one hand, we need to know what app is doing, and we need to know what resource we're deploying. On the other hand, we need to know what cluster is doing. And that's why, in my opinion, this middle level of observability is actually ideal for the deployment tool. Because deployment tool knows this context. It knows which of the resources of the cluster belongs to your app versus any other random resources, which even might resist in the same namespace, for example, right? But they still would not belong to this particular deployment. So I think in my advice for Kubernetes observability, think about how you will cover all three. How will your platform team take a look after the cluster or clusters in general, ensuring that they're healthy, updated, have enough resources provisioned, etc., or not over provisioned. Your development team will look into the actual app, the code. Is it healthy? It is running. Do I have any delays? Did I introduce some errors with the new update? And also, both of them will look into if my configuration is healthy, if it's provisioned as expected, if it's running as expected, if I see any errors with my pod starting, or maybe there is some broken service configuration. Now my network is dead. So both teams should look into that, and both teams will definitely benefit from this. Now the next small question is, it's really less important, but it's worth thinking about where I have it all at. Some customers, they want to put it all in one tool, which makes a lot of sense. It just make it more complicated. So basically you need to extract this information from your deployment manifest, maybe from your CD tool, then get it from the cluster, and then think about how you can present it in something like a Prometheus, Grafana, Datadog, New Relic, you name it. Some people say, okay, I will use just my Kubernetes dashboard or Rancher UI, for example, and I will look at the resources there. But then I need to, and this is actually quite challenging for developers because they might have like 50 different apps deployed, and then they need to find the resources which they actually care about. Again, doable, but hard. Some deployment tools, Octopus one of them, but not only, they give you observability over just the application you deployed, not going too deep in the weeds about learning what app is actually doing. So it's not like NPM monitoring. And also it's not cluster monitoring, so it's somewhere in the middle. So you just need to choose which one works better for you. And sometimes it's okay to have more than one tool for observability. So especially if they all exist on a certain in a certain step of the life cycle. Yeah.
Yeah,
Um, should we move on to compliance?
yeah. I mean that was I 100% agree with that observability. It is one of those very interesting things because it's a complete mind shift for me when I because I'm from a traditional Windows and Linux application host. I'm used to just okay, I'm just going to have New Relic tell me what's going on, and I just know what was deployed. Not now I have all this additional layers that I've never had to think about before. So it's a very fascinating topic for sure.
Right. So speaking of compliance, this is a short one. So no, it's just about we all have compliance. Big companies have compliance. We don't want to sacrifice it. We have these requirements. We don't want to sacrifice it moving to Kubernetes, and sometimes we do. Just let's not do that. So all the things which were true for previous models, they still true here. So we don't want to give admin access, especially to production environments. In this case, it means probably our platform application teams don't really need to have access to production classes via kubectl, and we don't really want them to, even for debugging and investigation purpose, we really don't want them to go there and run commands and try to fix configuration of flight. That's really hard. We can't audit that. We can't really ensure this is long-term sustainable. The guidance here, as well as with any other platform, just use the tools for that. Limit the access, use the special tools for your troubleshooting or issue investigation, for monitoring, for changes, use deployment tool to adjust the configuration. Don't go in the class and change it on the flight, ideally, if you can. And use granular permissions. So create roles in the cluster. Kubernetes does it, so that's the best way. Just ensure that security right in there. Use the roles in your CD tool, and just assign them granularly. So think about what each of your team members and each team should be able to do, and then just provision just enough. But the main thing, again, just avoid root access to everything, and just don't do troubleshooting of the flight with CLI. It doesn't always work. Yeah.
Yeah, I still can't believe the number of people who actually have kubectl access to their containers or their clusters in production. That's wild to me on something like that. So moving on a bit. Now, I would say this is a bit more of a spicy hot take more than anything, which is specifically around secrets. Every application has some sort of secret. The most common one being a connection string to a database, especially if you have a username and passwords in your connection string for a variety of reasons. I'm not here to judge. If you're storing secrets, I prefer to leverage secret stores and utilize their Kubernetes plugins to easily access those secret stores. I don't really like the thought of storing or using Git as a secret store, even if you're using sealed secrets. Primarily, this is due to the fact that it's a lot easier to move secrets between clusters, share secrets between clusters. You can also share secrets between applications. If that's something you want to do, it's much easier to rotate. And then, people just find all kinds of weird and interesting things just by monitoring even an encrypted value instead of a Git repo. You can see how often you rotate your secrets, or when was the last time a secret was rotated. You never know what people can glean from being able to see a secret, even if it's encrypted inside a Git. So again, the paranoid side in me says not to do it. Now, again, that's more of a spicy hot take on something along those lines versus, because I'm sure reasonable people will disagree. It's like, no, you should absolutely use sealed secrets. But again, I prefer secret stores on something along those lines, especially if you're using a cloud provider. Use their secret store. They've already provided it for you. Okay, move on a little bit to container runtimes. This was an interesting thing I didn't really think about till you brought it up, Kit, when we were working on this white paper.
Yeah, this is an interesting thing. So again, this is something and people miss all the time. So if you think about this, some microservices we deploy and update every hour, and then probably we don't really have issues with security for this. But some other containers, and this is something you might not even think straight away about, is some of them we deployed 6 months ago, and the microservice is just running. It's a small one. We don't really care. It does a job, and it's okay. It's been like this for 6 months, 9 months, 18 months. And but the app itself, it's not running in a vacuum. It's actually running a container with some other libraries and tools which you also installed in the container, or a container itself has some OS, etc. And what if one of these components, one of these libraries actually got vulnerability discovered. For the new app, for the app we deploy every day, we will fix that and won't even notice it's an actual process. For the older apps, for the containers deployed and created 9 months ago, that just won't happen. So this is just a small mark, small note to keep on the field. Just don't forget to constantly run security checks against your existing containers, against your microservices, which you maybe updated 9 months ago. And just sometimes, if there is vulnerability, without changing the code, you just need to deploy the container. Just fix the libraries and deploy the newer version, which just it will just save you a lot of from a lot of risks.
Yeah, and we're just going to move on, quickly discuss a little bit about the desired state and its impact on software delivery. So, Kit, I mean, you mentioned that when you're building for Kubernetes, it's a different consideration than before.
Yeah, so in a nutshell, there was a report recently, I think it was in the CNCF blog post, about how many companies use Kubernetes best practices. And it's just again, it's some kind of lack of knowledge, I think, which we can easily overcome if we just start thinking about what Kubernetes use to run our app, what we can put in the configuration to inform Kubernetes how we can best utilize the app and how we can, ensure that it's running as we need. So a few things which people constantly forget about. The main one is readiness and liveness probes. We can literally tell the cluster what we mean by the healthy app. And if it's not healthy, the cluster will just restart it. And it's so common that people just don't think about this, don't put it in the configuration, and then they have all sorts of problems to figure out that the app is not running and how to kill it. And then it's half manual process, but the cluster can just do it for you. The same thing is like CPU limits, RAM limits. So just don't let the apps kill each other in the cluster and compete for resources. Just use this. It's there. Kubernetes is smart enough to do this management for you. Security, again, Kubernetes already has role binding service accounts. You can prevent apps from influencing each other within the cluster. Sometimes we just don't know about this and don't think about this in advance. And also like disruptiveness budget, all the things. Just learn Kubernetes best practices, learn how you can direct Kubernetes in the way to manage your app, and just use it. That's basically my advice. Just don't forget about this. A little but important things in your configuration. All
Absolutely.
right.
Yeah, absolutely. I'm going to jump through some of the problems that you'd see at scale rather quickly because I know we're bumping up against our time limit. So I'm not going to dive too deeply into some of these things. Uh, so for YAML, I mean, one of the things you might see when you start running Kubernetes at scale is YAML sprawl. And we talked a little bit about this earlier when you have a branch per environment or a folder per environment or something along those lines. So just think about what would happen if you multiply all of those. And it's typically, this isn't a problem that's noticed until it's almost too late. It's like a boiled frog. You don't realize, you're sitting in boiling hot water till it's too late. Sorry, kid, I'm going to take over for this one as well. This is a case of, if you have, thinking about what happens to how you're going to handle your deployments. And if you just have do it yourself, running some scripts and running it through Jenkins, and it's just, the impact that could have. And, this can become quickly unmanageable again as you start doing these types of things at scale. Imagine if you have to change how you want to deploy, and that's just across all of your application. And then finally, how to handle any sort of things around access control and isolation, because one of the concerns is going to be around noisy neighbors. If you have multiple applications sharing the same cluster, that can impact one another on something like that. And so, how do you make sure that you keep everything managed? And there are alternatives to this, such as multiple clusters, but that has an additional complexity and cost on top of something along those lines. So sorry, I had to go through those rather quick, but yeah, we were bumping up against time. Thank you very much. If you have any questions, I'm happy to stay on and answer any of the questions. But again, thank you very much for listening to Kit and I talk.